Hey everyone, welcome back to the College Algebra playlist. In the previous video, we took a look at quadratic equations. Alright, and there are actually three methods for solving quadratic equations that I want to talk about in this playlist. Alright, we already saw the first, alright, that's factoring. The second is completing the square. And the third is the quadratic formula. Alright, so in this video, I want to talk about completing the square. All right, it's really good that we have another method for solving quadratic equations because not every expression we run into is factorable. All right, we can't always use factoring to solve it. All right, so let's dive into completing the square right now. Okay, here we go. Before we start talking about completing the square, we need to take a look at something called the square root property. All right, here we're asked to solve for x. Okay, we have x squared equals 25. All right, to isolate x, right, to get it by itself, what we need to do is take the square root of both sides. All right, the square root of something squared is just the something inside. All right, so on the left-hand side, that gives us x. All right, and then on the right-hand side, we have 5. Right, the square root of 25 is 5. Okay, so that's our solution. And it's true since 5 squared equals 25. All right, but we're missing a solution, right? We're missing something here. We also have negative 5 squared equals 25, right? A negative times a negative is a positive. All right, so what we need to do to make this more complete, instead of saying just 5 here, we need to say plus or minus 5. Okay, it turns out that whenever we're solving an equation with an unknown variable and we take the square root of both sides, we need to include a plus or minus. All right, so let's formalize that in a property. All right, the square root property states if x squared equals k, then x equals plus or minus square root of k, where k is a non-zero real number. All right, so when we take the square root of both sides of this equation here, right, we have a plus or minus. All right, so let's remember that moving forward. Here we're asked to solve for x. All right, we have x squared equals 8. Okay, to isolate x, we need to take the square root of both sides. Okay, so we're solving an equation for an unknown variable and we're taking the square root of both sides. That means we need to include a plus or minus right here. Okay, and we can simplify this a little bit, right? The square root of 8, we can rewrite that as 4 times 2 under the square root. All right, and then we can break that into two different radicals. Okay, the square root of 4 is just 2. So we get x equals plus or minus 2 square root of 2. All right, and that's our final answer. All right, let's try one more. Here we're asked to solve for x, all right, but isolating x is a little bit more complicated here. All right, the first thing we're going to do is divide both sides by 3. All right, when we do that, the 3's cancel on the left-hand side, and we're left with x minus 4 squared equals 5, right? 15 over 3 is 5. Okay, notice what this looks like, right? This is the factorization of a perfect square trinomial, x squared minus 8x plus 16. All right, perfect square trinomials are really nice because we can factor them like this, and then we can use the square root property to solve the quadratic equation. All right, we can just take the square root of both sides and isolate x. All right, so that's going to come up later when we start talking about completing the square. All right, so when we have this, when we have something that looks like this, we can take the square root of both sides. All right, and we get x minus 4 equals plus or minus root 5. All right, and then we add 4 to both sides to isolate x, and we get this. All right, this is our final answer. Okay, so now we're ready to start talking about this new method for solving quadratic equations, completing the square. All right, not all quadratic equations can be solved by factoring, and not all quadratic equations can be solved in their original form by using the square root property. Okay, we need a new method that always works for any values of a, b, and c in this equation here. All right, this is the standard form of a quadratic equation. All right, not every trinomial we run into is going to be factorable. All right? So we need a new method. The method of completing the square works for any values of a, b, and c. All right? Even if it's not factorable, we can use this method and it works. All right? The method essentially boils down to this. We add or subtract terms on both sides of the equation to get a perfect square trinomial. All right? Then we use the square root property. Right? We take the square root of both sides and then we isolate x. Okay? So this is an example of a desired result. All right? This is the factorization of a perfect square trinomial. All right? So the goal is to create one of those. All right? We're going to create a perfect square trinomial. Let's look at the method itself. All right? Here's the recipe. We're cooking up some solutions here. All right? We're going to use this example here, right, with specific values for a, b, and c, all right, to illustrate the recipe at each step. All right? The first step is to divide both sides of the equation by a. All right, in our example, we have a equals 2, so we get x squared plus 6x plus 4 equals 0. All right, that's what we get when we divide both sides of this equation by 2. Okay? We need to have a leading coefficient of 1 in order for completing the square to work. All right? So then we take the constant to the right-hand side. All right? In this case, we subtract 4 from both sides of this equation, and we get this. All right? And then, here's the key step. All right? Here's what we do to create a perfect square trinomial. We add b over 2 squared to both sides. All right? In our case, here, we have b equals 6. Okay? So we're going to take 6 over 2 squared, right? That's 3 squared, which is 9. We're going to take that and add it to both sides of the equation. And that will give us a perfect square trinomial on the left-hand side. All right? So let's take this result here to the top of the screen. All right? Here's the result from step 3. X squared plus 6x plus 9 equals 5. All right? Now we can factor the left-hand side as a perfect square trinomial, and we get x plus 3 squared equals 5. All right? And then we can take the square root of both sides. All right? And then we can isolate x. Here we get x plus 3 equals plus or minus root 5. All right, we subtract 3 from both sides, and we get x equals negative 3 plus or minus root 5. All right, and that's our solution. Okay? So that's the method of completing the square. All right? In this case, we ended up with some really nice numbers, all right? We didn't have any fractions involved. Okay, but most of the time, the numbers are going to be ugly, all right? We're going to have fractions to deal with. So let's take a look at an example like that right now, okay? Let's use the recipe to cook up some solutions to this equation here, all right? The first thing we're going to do is divide both sides by 2. All right, we need to get rid of this leading coefficient, okay? So when we do that, look what happens. We have some fractions, right? We have x squared plus 5 halves x plus 1 half equals 0. All right? But no problem, right? We can still follow the recipe to cook up our solutions, okay? We just need to be careful because we have fractions involved now. All right? So we're going to subtract 1 half from both sides, all right? And that gives us this, all right? Now we're ready to determine what we need to add to both sides to create a perfect square trinomial. All right? We're going to add b over 2 squared to both sides. All right, in our case, we have b equals 5 halves, okay? So we have 5 halves over 2, whole thing squared, all right? In parentheses, this simplifies to 5 over 4, all right? And when we square that, we get 25 over 16. Okay, so if we add this to both sides of the equation, we create a perfect square trinomial on the left-hand side. Okay, so let's go ahead and do that. All right, we add this to both sides. And look at what we have on the right-hand side, right? This is some fraction addition happening, all right? Which means we need to get a common denominator, okay? So we multiply negative 1 half by 8 over 8, all right? Let's take this result to the top of the screen. Okay? We have this multiplication here, and that gives us negative 8 over 16 plus 25 over 16, all right? 25 minus 8 is 17, so on the right-hand side we have 17 over 16, all right? We combined these two fractions into one because we had a common denominator, all right? Now we can factor the left-hand side as a perfect square trinomial. All right. Now, how do I know how to do this? Like, how do I know what this number should be right here? I'll let you in on a secret. All right. Here's the secret of completing the square. All right. The number that you put in this slot right here, it could be plus something or minus something. All right. It's always going to be b over 2. All right. In our case, we had 5 halves over 2, right, which is 5 fourths. So we add 5 fourths in this slot here, all right? And we can check this if we want to, right? If we FOIL this, we have x plus 5 fourths times x plus 5 fourths. If we FOIL that, we'll get this expression on the left, right? That's a perfect square trinomial, okay? So whenever you factor these things, remember that what goes in this slot here is b over 2, okay? So when we do that, we can take the square root of both sides, okay? So on the left, we're just left with x plus 5 fourths, all right? And on the right, look what happens here. I have root 17 over root 16, all right? I broke this radical up into 2 radicals, okay? The 1/2 power is being applied to this quotient, so I can take that 1/2 power and apply it to each piece of the quotient, all right? That's an exponent rule, all right? Let's take this result to the top of the screen. Okay. The square root of 16 is just 4. Okay, so the right-hand side simplifies nicely for us. And the next step is just to take this 5 fourths to the other side to isolate x. All right, we have x equals negative 5 fourths plus or minus root 17 over 4. All right, we have a common denominator, so we can condense these two fractions into one. All right, this is our final answer. All right. So completing the square takes a lot of work, but it always works, all right, no matter what your values are for A, B, and C. All right. We can visualize our solutions by plotting this graph here, all right? We have y equals 2x squared plus 5x plus 1. All right, this is what the curve looks like. That represents the equation, all right? And we just solved this equation in blue here, right? We found the x-intercepts of the graph, all right? So we know what the x-coordinates of these points are, all right? This one is negative 5 minus root 17 over 4, comma 0. And this one is negative 5 plus root 17 over 4, comma 0. All right? That does it for this video. Thank you for watching, and like and subscribe.